We're now going to talk about some effective techniques for modeling. What are the key points that we have to watch out for when we want to effectively model a domain and through the domain an application that is to operate? The first and maybe most important point is that the model and the implementation have to be bound together tightly. What we mean by that is that the implementation has to reflect our model being what we understand about the domain and about the way the application has to operate within the domain. And the implementation has to reflect that. In order to achieve such a tight binding between the model on the one hand and the implementation on the other hand, what we need is a common language that's based on the model. This is what we have talked about in other courses already. It's sometimes called the ubiquitous language. It is a language that is spoken by the entire team around any activities or any artifacts or any deliverables that derive from the project. This goes further than just having some terms that are shared by the different team members, by the developers, by the product owner, by domain experts, and so forth. It goes much further than that. It implies that these components of the language, these terms of the language, are also the basis for the implementation, so that function names, variable names, method names, whatever you have in your program based on the programming language you use, development paradigm that you use, that is based on the terms of the common language around the project. We want to therefore develop a knowledge-rich model. That is maybe obvious. If we want the implementation to reflect the model, then the model better be a knowledge-rich model so that we have all the knowledge that we would need for the implementation to fall back onto. We also do not want a complete model. What we mean by that, or what I mean by that, is that there are many concepts around a project, around a domain, that we might feel we should capture, but later on we might feel, we might see that they do not prove very useful. And those terms, those notions, those concepts should be dropped from the model. We should document and capture only those concepts and notions that prove useful with the discussion around the project and with the implementation and with the development of other deliverables around the project. In order to further bind the model and the implementation, it is important to use or to reflect the model in many different modes, in many different forms or contexts of expression. So the common language needs to be exercised. It needs to be spoken around the project by everybody involved. We can reflect the model in sketches. We can draw sketches as to how the implementation works. We can compare whether those sketches that reflect the implementation, what they mean if we interpret them on the level of the model, and whether we maybe derive some new insights from such sketches for the model, for the domain. And if we do that, if we have brainstorming sessions, if we sketch the internal relationships within the model and within the implementation, if we use the common language, then our discussions around the project become laboratories of the model, in which we evaluate different design options or different design variants by using a slightly different way of expressing something, of wording something. But we are trying out a new variant of the common language, which is at the same time a slightly different domain model that we are trying out. We will call this activity that I hinted to on the previous slide, we will call this activity knowledge crunching. Knowledge crunching is about discovering knowledge, exploring knowledge around the domain, around the requirements of the application, around the implementation. And what is crucial to knowledge crunching is that we want to find the relevant trickle in a torrent of information. Obviously, if we open up the floodgates, so to speak, and we research what there is to know about any domain that you can pick, you will find that there is a torrent of information available. It's easy to be overwhelmed by the amount of information that you can find. There will be textbooks, there will be research articles, there will be existing implementations, there will be open source projects around that domain, there will be all kinds of sources of information. What we need to do is we need to find the relevant trickle within that torrent of information. That is not a solitary activity. Knowledge crunching is not a solitary activity. You want to do this in a team. You want to have different roles involved in such knowledge crunching activities so that you can bounce ideas off of one another to improve the understanding of everybody involved. In knowledge crunching, we use raw information from many different sources. One source is the domain experts. Either we have interviewed them and we have recorded what they had to say, but it would be better if we have the domain experts on the team and we can involve them in these knowledge crunching activities. We want to draw upon the experience of the users of existing systems. They are normally a very good source. They have been using the system. They are often domain experts, at least in the specific workflows that they deal with. And they usually have experience, likes and don't likes from the existing systems. And that, of course, is a very rich source of information, very valuable source of information. The technical team that is working on the project will have prior experience from maybe totally different projects that involve the same programming language or that involved the same or similar libraries or frameworks. And they might also have prior experience from projects that are within the same domain. All this raw information is at our disposal, and we need to derive the relevant knowledge for this project from that wealth of information. The information comes in various forms. We obviously will have documents for the current project on which we're working. There are documents that are used in the business. There may be training manuals for users. There may be workflow recipes if you want. Like for example, when you go to a bank and you have a certain transaction that you want to perform, and the bank clerk has never performed this before, they pull out a folder and they flip through it, and that's their manual with all the recipes, with all the instructions as to what are the steps to do to perform this transaction. So these types of documents are also very useful. They're also a source for knowledge crunching. And then there is talk, talk, and talk. Now, some of you might think that talk is cheap. Well, through talking about the different perspectives on the domain knowledge, on the knowledge that revolves around the project, we bring the relevant concepts to the fore. We emphasize them, or we explore them, whichever perspective you want to take. So that talk is enormously valuable. It also exercises the ubiquitous language that is spoken all around the project, and it is valuable for that reason also. So do not disregard talk. It's enormously important that you talk a lot within your team and with different roles on the team. The team not only consisting of the developers, but also of the product owner and the domain experts and so forth. Whoever you can involve in these rounds of talk, they will be a source of additional knowledge for the project. There have been various approaches to software development, software design. In particular, one that is frequently quoted is the waterfall model. I have a link on Moodle that concerns the waterfall model. I strongly invite you to explore that link a little bit and maybe to go back to the original paper that reports on the waterfall model. The reason is that the waterfall model is often quoted as the prototype for a forward-only approach to software development, maybe even with different teams involved. And of course, if we think of the waterfall model in that way, then it's not a good idea. It has no feedback. There is no improvement of the earlier stage by insights of a later stage. However, there is quite some misunderstanding in the waterfall model, and also in the way some companies have employed the waterfall model. The original waterfall model was not intended to be applied in this way. But read that link for yourself, explore the topic for yourself to get a picture on this. Iterative approaches are often claimed to be superior to the waterfall model. However, if there is an iterative approach that uses different teams, it does iterate, but it uses different teams, then this approach is also not going to build up knowledge around the project. So in an iterative approach, you may have domain experts describing a feature. Then developers implement the feature. And what happens next? Well, the system is going to be refactored so that it remains somewhat maintainable or extensible. But the developers do not really learn the principles of the domain. The domain experts describe a feature based on their understanding of what is necessary, but they don't bring that knowledge to the developers. So the developers don't become knowledgeable about the domain. They just see the feature they're supposed to implement. And so in such a project, you can iterate this process, but since the developers do not gain any deeper insight into the domain, they can also not contextualize their findings about, for example, refactorings that they have done into the context of the domain description, and so therefore they cannot bring knowledge back to the domain experts. Imagine, on the other hand, that the developers are knowledgeable about the domain because they have learned from the domain experts the principles of the domain. In that case, when they see a necessity to refactor something in the implementation, they can discuss what this means in the context of the domain model with the domain experts. And so the whole team can progress to a stage where the team is able to discover new features that were previously unimaginable because neither the developers nor the domain experts had the insight or were in the position to have the insight that was necessary to come up with that feature. These drawbacks of other approaches are counteracted or remedied by a domain-driven approach. With the constant crunching, knowledge crunching around the domain model, developers are put in a position where they need to learn the important principles of the business. And as I just said, that puts them in a position to contextualize certain insights that they have based on the implementation in such a way that the domain model that the domain experts are responsible for can be improved. So the domain experts refine their understanding by this communication of the essentials. So it's a back and forth. The model will, after some crunching in this way, reflect deep knowledge of the business. And this is obviously an important feature or important outcome. And we do understand that models are not perfect, but they're evolving. So there is no aim to have a model and then be done with domain modeling. Instead, the understanding is that even though we do use a model to implement software based upon it, the model is evolving hand in hand with the implementation. So if we feel that we have to make a change to the implementation, we do not make that change without reflecting that change back in the model. Will it impact the model in such a way that there is a change to the model, or is it covered by our current model? Is it already reflected in our current model? Well, likely if we feel a need to make a substantial change in the implementation, then it goes hand in hand with a different view upon the model, and so it will be accompanied by a change in the model. A suggestion here is to consider software development a continuous learning exercise. To be aware that when we set out to write software, we never know enough. There's always more in different areas that we would want to know in order to better be able to complete the project. Often, we don't even realize how much we do not know. That is, how little we know. There is technical knowledge that we lack. Maybe we're employing a framework or a new programming language or several programming languages, and there are some technical aspects of the interaction between the different languages or the different frameworks that we don't know about yet. But we also may find that we're still learning domain modeling skills, that we lack some domain modeling skills, and so therefore we learn something new in that direction. And there is the specific learning about the domain. We may not have worked in that domain before, and even if we have, there might be new insights that we're still learning about. There is an interesting thought or an interesting relationship considered about software, knowledge, and ignorance. It goes back to a person called Philip Amour, who is a software engineering consultant. And this is already, I would guess, 25 years old, maybe not quite, maybe just 20, maybe even 30. I haven't looked it up recently, but what it says is that software development can be seen and should be seen as a knowledge acquisition activity. And if we view software development as a knowledge acquisition activity, we can look at knowledge acquisition from a slightly different perspective. And from that slightly different perspective, knowledge acquisition is ignorance reduction. So the perspective or the paradigm here is that software is not a product. Instead, it is viewed as a medium for storing knowledge. That medium has certain properties that other media do not have. A movie, for example, may also be viewed as a medium for storing knowledge that has different properties. In particular, it is not interactive. If we view software development as knowledge reduction and as the creation of, the creation is maybe the capturing of knowledge in this particular medium, then software development is no longer a product producing activity. We do no longer have the focus on some end product, and the whole project just rushes towards the completion of that end product, which in the past has turned out to be, to say it mildly, a problematic way of viewing software development. Instead, what's proposed here is that we should view software development as a knowledge acquisition activity. And since knowledge is just another side of the coin of ignorance, if we view software development as knowledge acquisition, then if we turn that around, then it is an ignorance reduction activity. And Philip Amour coined the 5 levels of ignorance, and I don't expect you to memorize these levels of ignorance, but it's quite helpful to think about them and to consider where on the 5 levels of ignorance are you currently operating. So if we are on the 0th order of ignorance, we have a lack of ignorance. And obviously, if we have a lack of ignorance, that means we have full knowledge. So I have 0th order of ignorance when I provably know something, and I can demonstrate my lack of ignorance in some tangible form, such as by building a system that satisfies the user. So the presence of the knowledge has to be provable, otherwise we might be self-deceiving and we might not know it at all. We might just think we do, but we might not. So we require developers to test and prove that they tested their systems rather than simply taking their word for it. If you have built a system that fully satisfies the user, and you have created tests that witness that The things the user asked for are actually provided by the system. You have shown, you have demonstrated your lack of ignorance in a tangible form, and you have proved that you have that lack of ignorance, that you didn't just satisfy the user's needs by accident. When we have first order ignorance, we lack knowledge. That is still a relatively simple state to describe. So I have first order ignorance when I don't know something, but I know I don't know it. How high is the Eiffel Tower? Well, I know that I don't know that, so I have to look it up. So first order of ignorance is, in a way, a kind of knowledge. I know what I don't know. I know that I don't know how high the Eiffel Tower is. So I know that I have to look that up. So first order of ignorance is easy to deal with. We just have to find a resource where that knowledge is presented and consult that resource, and we have eliminated the first order of ignorance and turned it into zero order of ignorance. Second order of ignorance is then a lack of awareness. So here, I don't know that I don't know. So I have second order of ignorance when I don't know that I don't know something. Not only am I ignorant of it, I'm unaware that this is to be known. I'm unaware of what that something might be. So the unknown unknowns. Even an abbreviation exists on UNK. So the unknown unknowns. Obviously, these are more dangerous than lack of knowledge. If I simply have lack of knowledge, I'm aware that I do not know this, and so I can remedy the situation. In a lack of awareness, I'm not aware that I don't know this. I do not know what it is that I don't know, and so I'm not in a good position to remedy the situation. First have to become aware of what it is that I'm lacking in knowledge to then remedy that situation. On the next order, we have lack of process. So I have third order ignorance when I don't know of a suitably efficient way to find out that I don't know something. So what it means is I cannot resolve my second order ignorance. If I do have second order ignorance, I do not know that I do not know something, but I don't have third order ignorance, meaning that I do have a process of finding out what it is that I don't know, then I have a way of remedying that situation. If I have lack of process, that means that I don't know of a way of coming up with what it is that I don't know. So I'm even more ignorant. Obviously, why it's stated as the third order of ignorance. We have added here the qualifier suitably efficient. There's a default process that eliminates the lack of awareness. We should say there is a default second order of ignorance process. That is, ship it. If I ship it, then you wait. If you didn't know something that you should have known, the customers will call. Obviously, that is not the way we should conduct business. It's not the way we should do our engineering. It's, in my opinion, nothing that we should be proud of. And not just in my opinion. So, shipping the system is an effective process, but it is not suitable and it is not efficient. The last level, the fifth level, actually it's the fifth level, fourth order of ignorance since we started counting at 0, is meta-ignorance. And I have fourth order ignorance when I don't know about the 5 order of ignorance, which you no longer have. You no longer have meta-ignorance. We at least eliminated that. And we can say that the 5 orders of ignorance play a tremendously important role in system development. Our job is often the reduction of second order ignorance, right? Often we are not aware of all the things that we don't know. And by talking to the domain experts, by talking to the product owner, by talking to the users, to the clients, we find out what it is that we don't know, and we can then research the details, what the specific knowledge is that we lack. All systems processes and methodologies are third order of ignorance processes. So they're processes whose job is to convert second order of ignorance into first order of ignorance. And we already talked about the fact that when I have first order of ignorance, it is straightforward to turn it into 0th order of ignorance. If we use this framework of these 5 levels of ignorance, we can see that second order of ignorance and third order of ignorance explain most of the problems in systems development. It is either that I don't know what I don't know that throws us off, or it is that I don't have a way of finding out what it is that I don't know. Management systems in companies, in enterprises, in development enterprises, are often set up to deal with 0 order of ignorance. We have a person who knows. Or with first order of ignorance, we know what we have to look up. So often these types of management are not set up to properly deal with an activity that needs to uncover what we don't know, or even explore processes of uncovering what we don't know, and so forth. So this is an interesting framework to keep in the back of your mind and to ask yourself, if there's a problem, what is this an example of? In which category, in which level, in which order of ignorance does it fall? Is this an instance of not having process, or is this just an instance of not knowing what it is we're not knowing? These will very likely be the most frequent sources of problems. In order to get to knowledge-rich designs, we need to go beyond the simple approach of finding the nouns. So you have heard this before. Some people say for object-oriented design and analysis, you should just go for the nouns, identify the nouns, and that gives you the objects that you need to deal with, and then you look for the verbs, and that gives you the functions. For knowledge-rich design, I mean, I'm not saying that you shouldn't apply this simple approach, but for knowledge-rich designs, we want to go beyond that. We want to identify business rules and activities, and that already goes well beyond the simple approach of finding. We may discover inconsistencies in the business rules. That is to be expected. The reason for that is that business rules are normally formulated for humans, and humans are pretty good at dealing with inconsistencies. They just work with the inconsistency in the way that they know when to apply this rule and when to apply that rule, even if people haven't explicitly told them. That's just because they apply common sense. Well, if we want to use the business rules as a foundation for the implementation, we need those to be inconsistent, because we are rigorously representing the business rules. So we might discover inconsistencies, and we will have to deal with those inconsistencies. Another thing that can happen when we work towards knowledge-rich designs, another thing that we want to happen, is that we bring hidden concepts from the code to the model, so that we might discover some hidden concept, or we might have the feeling that there is some hidden concept missing from our modeling, and to then explore the model to include that hidden concept. So next we're going to talk about an example where we are extracting a hidden concept. We start out, this is taken from an actual project that the author of the book that we're using for this course has experienced or worked on. And in that project, the idea was that there is a voyage. It was about shipping. There is a voyage, and associated with that voyage is any number of cargo. Straightforward so far. Then in discussions with the domain experts, it was revealed that overbooking is a common business practice, and that this would have to be incorporated in the system. In this situation, where we have a voyage composed of cargo, we might come up with the following source code. So we have a function make booking here that takes a cargo and a voyage, and assume that on voyage we have a method capacity, and we assume that on cargo we have a size, and we determine the maximum that we want to allow for booking, taking capacity of the voyage and multiplying it by 1, and then we check whether the book cargo size, what's already booked on the voyage, that of course is assumed to be another method available on this voyage, plus the cargo size, the size of the cargo that we are booking for this voyage. If that is greater than the max booking that we want to allow, then -1 is returned as an indicator for failure. In the other case, we obtain a confirmation number from a sequence of numbers, and we add the cargo with that confirmation number. What's wrong with doing it this way? Well, one of the things that's wrong is that we have a business rule here, namely that we should allow overbooking on a voyage, shipping. And that business rule is hidden within a guard inside the source code, and it's not being made explicit. In particular, that business rule is also not reflected in the model. So what we do instead is we change the model, and we indicate that the relationship between a voyage and all the cargo associated with that voyage is governed by an overbooking policy. And the overbooking policy brings in the constraint here that the sum of all the cargo's sizes must be less than, I think it should be less or equal, than the capacity of the voyage multiplied 1 by 1 with this overbooking. So if we change the model to this version, then we are accounting for the fact that there is this overbooking policy in the domain, and that the overbooking policy brings in this constraint. This is an application of the strategy pattern. The strategy pattern, the basic idea of the strategy pattern is that we parameterize something over a certain method of doing it. So in this case here, we have the method over which we parameterize is the overbooking policy, determining whether the cargo should be accepted as an additional booking. That is the method over which we parameterize. In object-oriented programming languages, purely object-oriented programming, older versions of Java, the overbooking policy would have to be wrapped in a class, and we could have several different objects, instances of that overbooking class. The overbooking policy would provide a method, isAllowed, and the sole purpose of the overbooking policy class would be to be a wrapper for this method. In more recent versions of Java that allow us to use higher order functions, and in programming languages like Python, or even more functional programming languages like OCaml or Haskell, we would be able to just parameterize over the actual function itself. We would be able to supply the function that should be used in order to determine whether the booking is allowed or not. That function could directly be provided as a parameter, instead of having to provide an object that is an instance of the overbooking policy class, with the overbooking policy class having the sole purpose of wrapping that function. But whatever the programming language that we use, in any case, it is an application of the strategy pattern, making a strategy, an algorithm, a parameter. Our makeBooking function could then look like this. What we assume here is that there is a variable overbooking policy which we possibly set when we create a voyage object, or if this is a service, if this is a booking service, then when we create the booking service, we may supply the overbooking policy to be used, which is then set to this local variable overbooking policy. Whichever way we do this is not really that important. The main point is that the source code now tells us that if the overbooking policy is allowed with the voyage and the cargo is not true, then we return -1. So what we gain is that the source code becomes much closer to a specification of the business rule. Within the overbooking policy class, we would then find a Boolean is allowed that takes a cargo and a voyage, and that does exactly what we did before, but now this is within a class overbooking policy, within the function is allowed. And so it speaks much more the language of the domain expert. Not every detail that we can identify on our on our implementation should become a strategy class. So which aspects, which concerns should become strategy classes? Well, here we're dealing with the business rule. Overbooking is a central concept in the domain of shipping. And so it should be reflected in the model, and if the model and the implementation are to agree, then it should obviously also be reflected in the implementation. It should be made explicit because, as I said before, overbooking is an important business rule. If we make it explicit in this way, not only is it understandable by the domain expert, but it is also much easier to talk about it among the developers, because it now has a class in which it resides. Or if you're not working with a purely object-oriented programming language, then there still would be a data type that reflects what kind of function can be passed in for determining whether this would be allowed by the overbooking policy. And so the type name, for example, could then be what talks about this insight of, or that represents this insight that there is an explicit overbooking policy here at play. We want to arrive at deep models. We want to eventually have a deep model. In order to get to a deep model, in order to arrive there, we need to discard superficial model elements. Those model elements that do not contribute to a deep understanding of the domain. And as we do that, as we discard such superficial model elements, more subtle abstractions can emerge, or more subtle changes to the abstractions we had previously conceived of may emerge. And one example is our shipping domain, shipping cargo. In an initial model that was developed on a project of which the author of the book that we use talks or writes, in an initial model, it described cargo and itineraries and so forth. And there were a few months of development that took place. And after that time, it turned out that the domain experts with whom the team was working were much more concerned with transfers of legal and practical responsibility than they were with itineraries and so forth. So the focus was, well, you might say slightly different to what the developer team initially thought. From the perspective of the domain experts, that might have been a fundamental difference. And they were concerned with important steps that took place while the cargo was sitting in a warehouse. So it was entirely possible that there was nothing happening on the itinerary to the cargo. It wasn't being shipped. It was just sitting around somewhere in a warehouse. But while it was sitting around, there was some transfer of legal or practical responsibility. And that was an important step from the perspective of the domain experts. Likewise, there was cargo involved in complex physical steps that took place, but they didn't have any influence on the legal and practical responsibilities for the cargo, and so they were of no interest to the business decisions of the domain experts. So this is something that the team only realized after a few months of working on the project. But of course, these are important and deep insights that improve the situation of the development team, improve their knowledge about the domain, and therefore allow them to develop a system that is much closer to the actual needs and to the actual way the users think about their needs. So knowledge crunching is exploration. It's an explorative approach to understanding the domain. That concludes the lecture on effective domain modeling. Thanks for watching.